Welcome to the Hodja on Everything. The Space. Chapter 2. Tailoring the Spacetime Fabric. In the previous episode, we explored humanity's best current explanation for the universe's beginning. We followed the expanding cosmos backwards towards the Big Bang, discovered why scientists believe the universe had a beginning, and encountered some of the mysteries that still surround that extraordinary moment. We also learned something equally important. The more we discover about the universe, the more interesting the unanswered questions become. The Big Bang gave us a beginning, but it also created a new problem. If the universe began nearly 14 billion years ago, where exactly did it begin? And when exactly did it begin? As it turns out, those two questions may be much harder to separate than they first appear. Tailors work with fabric. They cut it, shape it, and somehow turn a flat piece of cloth into something that fits reality remarkably well. Physicists, meanwhile, often speak about the fabric of spacetime, which raises an obvious question. If the universe has a fabric, who tailored it? Unfortunately, physics has not yet identified a cosmic tailor, a universal sewing machine, or an intergalactic dry cleaning service. What it has discovered instead is something far stranger. Space and time may not be separate things at all. They may be part of the same structure. And once you start pulling on that thread, reality begins to behave in ways that would make even the most patient tailor question their career choices. For most of human history, space and time seemed perfectly straightforward. Space was where things happened. Time was when things happened. Nobody felt any particular need to merge them. If somebody asked where your house was, you gave directions. If somebody asked when dinner started, you looked at a clock. These appeared to be completely different questions. The universe seemed to agree. Then along came Albert Einstein and politely informed everyone that the universe was under no obligation whatsoever to respect common sense. Before Einstein, space and time were neighbors. After Einstein, they got married. This idea emerged from a surprisingly simple observation. Imagine two people watching the same event while moving at different speeds. Classical physics assumed that both observers would agree on time, even if they disagreed about distance. Einstein suggested something much more radical. What if time itself behaved differently depending on how you moved? What if space and time adjusted themselves together to preserve something deeper? That deeper thing turned out to be the speed of light. Reality, apparently, is willing to bend space, stretch time, and confuse generations of students before it allows the speed of light to change. This is where relativity begins. And this is usually the point where common sense survives for about 10 minutes before quietly leaving the room. We spend our lives believing that time flows equally for everyone. 1 second is 1 second. A minute is a minute. Surely that is simple enough. Yet experiments repeatedly demonstrate that clocks moving at different speeds do not agree with one another. Time itself can stretch. Not because clocks are broken, but because reality genuinely behaves that way. The universe has many fascinating features. One of them is its complete indifference to our preferences. The phenomenon is called time dilation. The faster you travel, the more slowly time passes relative to someone moving more slowly. Science fiction often presents this as an exotic possibility for future space travel, but it is already real. In fact, one of my favorite scientific facts is that GPS satellites must account for relativistic effects to function correctly. Every day, millions of people use Einstein's theories to find coffee shops, train stations, restaurants, and occasionally the wrong motorway exit. Einstein spent years revolutionizing physics, and one of the practical outcomes is that he now quietly helps people find the nearest cappuccino. Naturally, once people hear about time dilation, they immediately start looking for loopholes. Students occasionally wonder whether relativity might provide useful arguments regarding assignment deadlines. If time passes more slowly at high speeds, perhaps arriving late is merely a matter of perspective. Sadly, university regulations remain stubbornly Newtonian. Relativity has transformed modern physics, but it has not yet succeeded in extending coursework deadlines. Space turns out to be equally strange. If time changes depending on motion, then distance changes as well. Objects moving at extremely high speeds become shorter in the direction of travel. This is called length contraction. The universe appears determined to maintain balance. If time stretches, space shrinks. If space shrinks, time stretches. Somewhere inside reality, there seems to be an accountant making sure everything balances perfectly. Physicists call this mathematics. The rest of us occasionally call it suspicious. The deeper implication is that space and time are not separate arenas. They form a single four-dimensional structure known as spacetime. Every event in the universe has not only a location, but also a moment. where and when become part of the same description. Imagine a map. A normal map tells you where something is. A space-time map tells you where and when it is. In a sense, every human life can be imagined as a path moving through space-time. Physicists call this a world line. Personally, I think it sounds like the title of a progressive rock album. One consequence of spacetime is the relativity of simultaneity. This phrase sounds intimidating, but the idea is wonderfully strange. Events that appear simultaneous to one observer may not appear simultaneous to another observer moving differently. In other words, two people can disagree about whether two things happened at the same time, and both may be correct. Somewhere in the universe, there are probably two physicists arguing about whether an event happened simultaneously with another event. The disturbing part is that relativity suggests both of them might be right. This leads us to one of my favorite images in physics, the light cone. Imagine every event surrounded by a cone defining what can influence it and what it can influence in return. Anything outside that cone cannot affect the event unless it travels faster than light. The light cone effectively organizes causality itself. It tells reality what is allowed to communicate with what. Looking at some corners of social media, I occasionally find myself wishing we could apply light cones to online discussions as well. Space-time becomes even stranger when gravity enters the story. Newton described gravity as a force pulling objects together. Einstein suggested something more elegant. Massive objects curve space-time itself. Planets are not being pulled around the sun by invisible ropes. They are simply following the curves created by the sun's presence. Imagine placing a heavy bowling ball on a mattress. The mattress bends. Smaller objects roll toward it. The analogy is imperfect, but it captures the basic idea. Tailors usually charge extra for alterations. Fortunately, spacetime appears to provide curvature free of charge. One reason I love these ideas is that they force us to see ourselves differently. Human beings spend much of their lives feeling stationary. Yet at this very moment you are rotating with Earth, orbiting the Sun, traveling around the center of the Milky Way, and moving through an expanding universe. We are astonishingly busy for a species that regularly complains about being tired. From a cosmic perspective, even sitting quietly in a chair is a remarkably energetic activity. The more we learn about spacetime, the stranger reality appears. We discover that clocks disagree, rulers shrink, simultaneity becomes negotiable, and gravity emerges from geometry itself. Yet somehow these bizarre ideas consistently survive experimental testing. Nature keeps confirming them. This is one of the reasons science remains so exciting. Reality repeatedly proves itself more imaginative than fiction. If a novelist had invented relativity before Einstein, editors might have rejected it for being unrealistic. Perhaps the most beautiful aspect of spacetime is that it unifies things we once thought separate. Space and time, distance and duration, motion and observation all become parts of a larger structure. Tailors create suits that fit people. Physics attempts something far more ambitious, a model of reality that fits the universe itself. The result is not always intuitive. It is not always comfortable, but it is endlessly fascinating. Today, we explored one of the most revolutionary ideas in the history of science. We discovered that space and time are woven together into a single fabric, that motion changes the passage of time, that observers may disagree about simultaneity, and that gravity itself may be the geometry of space-time. We also learned that Einstein helps people find coffee shops, that students cannot use relativity to escape deadlines, and that common sense occasionally requires professional supervision when discussing cosmology. In the next episode, we will zoom out from spacetime itself and explore the great structures that inhabit it. We will travel through galaxies, visit the spiral arms of the Milky Way, stop briefly in our own cosmic neighborhood, the Orion Spur, and witness the future collision between our galaxy and Andromeda. Because if spacetime is the stage, it is finally time to meet some of the actors. This concludes Chapter 2 of The Space, Tailoring the Space-Time Fabric. Thanks for listening. See you in the next episode.